welcome to another session in this series. In this session, we start with question number 63. Previously, we ended on 62. Okay, now let's start with question number 63. It says, subtract this from the sum of this and this. So that means we add this and this, then we subtract this. Okay, that's what the question means. So let's do that. So let's add what we are supposed to add, which is 1 over 2 multiplying a minus b plus c plus 1 over 2 multiplying a plus b minus c. Now we are supposed to subtract what? Subtract this from our sum. Okay, so that will give us minus 1 over 2 a minus b minus c. So this is what you're supposed to simplify. Okay, so now how we can see that these are 3 terms. Okay, let me use different colors so you can see. This is 1, this is another term, and this another term. Okay, 3 terms. So now in each of these 3 terms, what is common between them? You have half, 1 over 2, 1 over 2, 1 over 2. So you can what? Factor 1 over 2 out. Okay, we can factor 1 over 2 out. Let's factor 1 over 2 out. 1 over 2. Then in the bracket, you'll be left with the rest. Okay, so if you factor 1 over 2 out from here, we'll be left with this. 1 over 2 out from here, we'll be left with this. And then 1 over 2 from here will be left with negative. Because of this negative will affect everything. Okay, cool. So let's do that. So we're going to have a minus b plus c plus a plus b minus c. Then minus, this minus will affect this, so we get minus a. Then plus, because negate positive. Okay, so plus b, and also negate positive, so plus c. Okay, plus c. That's it. Okay, so now we just need to simplify. So we have negative b and positive b will cancel each other because this subtract and addition. Positive c and then negative c also goes. So now we are left with what? This is a plus a, 2a, and then on the other side we have another minus a over here, so minus a. Okay, then plus b plus c, all multiplying 1 over 2. Okay, so let's rewrite it. So what do we have? 1 over 2 multiplying 2a minus a will give us what? A. Okay, so multiplying a plus then this side, which is b plus c. So that is our answer. Half multiplying a plus b plus c, which is a. Okay, which is a. All right, let's move on to question number 64. It says simplifying this. So as usual, we find the LCM. The LCM is x squared minus 25. But this looks like what? A difference of 2 squares, because this 25 can be written as 5 squared. So x squared minus 5 squared is a difference of 2 squares, right? Okay, so let's write that at once. So we have x plus 5, x minus 5. Okay, this whole expression is the same as this. Okay, cool. So now let's deal with the numerators. Okay, so now let's go back. X plus 5 cancels x plus 5. You are left with what? X minus 5, and that will multiply 1. Okay, so you have x minus 5. Okay, then minus. Now s squared minus 25 is this, which is the same as this, so it cancels out. Okay, giving us 1, and this 1 will multiply the numerator over here. Okay, this will give us 2 multiplying x plus 2. So let's simplify that. We have x minus 5 minus 2x minus 4 all over x squared minus 25. Okay, so what do you have? Negative x minus 9 all over x squared minus 25. Okay, good. So that is our answer. Do we have it there? Yes, we do have it, which is D. Okay, cool. Let's move on to question number 65. It says find the common factor of 9r squared minus 16s and 12r plus 16s. So what we do is we first find the factors of this and also the factors of this, and then we compare which one is common. Okay, so let's do the first one, which is 9r squared minus 16s squared. And this is the same as 3r squared, okay, minus 4s squared. Okay, because 3r squared is the same as this, and 16a squared is the same as this. Okay, so now we know how to handle difference of two squares, right? We add and we subtract. 3r plus s multiplying 3r minus s. So this is our first part. Okay, let's name it equation 1. Now let's go to the second one, which is 12r plus 16s. Now when you look at this, we can easily factor 4 out. 4 is a common factor, so we can factor 4 out. Then we'll be left with 3r plus 4s. Okay, so let's call this equation 2. Now if you compare equation 1 and 2, this is 1, not equation but like the expression 1, and then this, what is common? 3r plus s is common, right? 3r plus s is common, so that is the common factor, 3r plus 4s. Sorry, over here it's supposed to be 4s, not s. This side is supposed to be 4s and also 4s. I made a mistake because the difference of two squares, and this is 4s, not just s. So let's correct it. Let's write 4s. Okay, so we can see that the common factor is 3r plus 4s, 3r plus 4s. Okay, so that is D. Cool. Let's move on to question number 66. It says simplify this. Okay, so now let's write it. We have m squared minus n squared all over n minus n. Cool. Now at a glance you can see that this looks like a difference of two squares. Okay, now this difference of two squares, the m term is what comes first. But when you look at the bottom, the term of the bottom, which can lead to a positive cancellation, to simplify, it starts with n. Okay, so what we can do is we try to make this one, the numerator, look like something like this. Okay, so that n will come first. Okay, so let's try to do that. So if you bring n first, it becomes negative n squared plus m squared all over n minus n. Okay, cool. Now this one is looking funny. Okay, this thing is looking funny because it doesn't really look like the difference of two squares. Of course, the difference of two squares if m is brought to the front, right? Cool. But there's a way we can still make this a difference of two squares. What we can do is try to factor out this negative. Okay, this negative, we can factor it out and see what happens. So if you factor it out, you are going to have negative 1 multiplying n squared minus m squared all over n minus m. So if you expand this, we should get what? This. Okay, because negative 1 times n squared will give us negative n, and then negative 1 times negative m squared will give us what? Positive, because negative pop. Okay, so now you can see that now we have a proper what? The difference of two squares that looks like this. Okay, cool. So now let's simplify. We're going to have, we still have our negative 1. Okay, negative 1 times n plus m n minus m all over n minus m. Okay, so the n minus m will cancel each other, and finally you have what? Negative 1 times n plus m, which will give us what? Negative n minus m. So that is our answer. And this can also be written in the form as negative m minus n. We just shifted it. Okay, it's also the same thing. So our answer will be what? B. All right, thank you so much for watching this series. In the next session, we'll move on to question number 67. See you again next time. Bye.